Hi, I'm Breckell from Electronics, and today we're going to talk about pulse width modulation and how it's used within an inverter drive to control an AC electric motor. Inverter drives are used in a wide range of applications in industry, be it controlling fans, pumps, conveyors, machine tools, virtually every application. They offer a number of advantages over more traditional methods of starting and controlling motors, such as a direct online or a star-delta starter. Essentially, an inverter drive lets you vary the speed of the motor. If you think about a traditional direct online starter, when the motor, for example in an HVAC or air conditioning system is started up, it immediately runs to full speed. If you then want to control the airflow, it has to be done through physical dampers or louvers being opened and closed. This is very inefficient in terms of energy usage. Another way to think about it would be, imagine driving your car and essentially running the engine at full speed and having to use the brakes to speed up or slow down. In terms of the energy you can save, it's quite considerable. If we take an example of a 10% speed reduction, you'd naturally assume that the motor would use maybe 90% of its power. In reality, because of the cube rule, what you're actually using is 90% cubed, so 90% times 90% times 90%. So in reality, for a 10% speed reduction, you're actually going to only use 73% of the energy. This is particularly important because if you think a lot of these fans, motors, pumps and conveyors are running 100% of the time. In terms of the layout of how an inverter is connected up, it essentially takes in the AC sine wave, it's fed into the frequency inverter, and the inverter creates a pseudo-square sine wave coming out, which is fed into the motor. The inverter is able to vary the amplitude and the frequency to control the speed. This is a typical layout of an inverter. So we can see up here we have the AC power coming in. This is fed into a DC bridge rectifier, which converts the AC into DC. It then travels along the DC bus and is fed into a series of transistors. These are called IGBTs. Think of these as very fast electronic switches. And these are what are switching on and off very, very quickly to give us that AC sine wave to drive the motor and control its speed. As I said with a transistor, in this case this is what we call an IGBT, which is an insulated gate bipolar transistor. It's a very, very fast electronic switch. And these will switch on at frequencies up to between 2 and 15 kilohertz. So they're pulsing very, very quickly. Here we actually see that on the bottom there, this is the output of the IGBTs on one of the single phases. And we can see that they're switching on and off very, very quickly, and we're varying the physical size and the width of the pulses. Because an electric motor basically has a series of copper coils inside, it doesn't see the individual pulses but the average. So what the motor sees from these pulses is what you'll see on the top here, which is the sine wave. Now by varying the width of these pulses, we can obviously vary the amplitude and the power to the motor. Here's an animated version, but so as you can see, as we increase the width, the amplitude of the sine wave that the motor sees increases. In addition to that, we can also vary the frequency. And by basically switching on those pulses on and off quicker, we can vary the frequency to the motor, giving us better control as well. So inverter drives and pulse width modulation are very important both for the controller motors and for power saving within industry. However, it does come at a price. Because those transistors we looked at are switching very, very quickly, again remember between 2 and 15 kilohertz, and they're what we call a nonlinear load, there is a case where a certain type of interference called harmonic distortion can be created. And this harmonic distortion can cause all sorts of issues within the control panel in terms of comm circuits and certain other electronic goods. And this is something we'll be covering in our next Omron panel tech tip. If you'd like to know any more about Omron, you can visit our website at industrial.omron.eu, or you can contact us directly for our technical team in the UK at ukts@omron.com. Thanks very much.